It's awesome being here again, isn't it? 12 months on. I'm going to start with a small story, then I'll get into the slide deck, which is that 12 months ago, I came here to Spatial Data Science Conference with Javier. We sat in the room outdoors. We talked about what we can do with our partners. 6 months later, I was dressed as Elvis with Javier in Las Vegas. So all I was saying is be very careful what you say you're going to do with Javier, because you never know where it's going to end. Hello, everybody. My name's Phil Cooper. I'm the Geospatial Tech BD lead. Like all foundational models, my job title seems to change every couple of months. I'm going to talk to you about a few basic things about AWS, but contractually I have to say S3 at least 10 times. So please monitor me and feel to check me afterwards. Geospatial data is big, and it's getting bigger. As I informed my daughter's computer science teacher, who didn't know what an exabyte was. That was fun. Geospatial data sits in S3. S3 is, for AWS and our partners and our customers who we obsess over, an authoritative source for geospatial data. It's been fascinating already today to see the data sets being presented. If you've never seen it, go to the Earth on AWS website. We have over 160 petabytes of geospatial data openly available. And many, many customers and many, many partners start their life and start their businesses running with that geospatial data store. That's the link. Interestingly as well, we make tools available with our partners on open source tools because access to data is critical. And as more and more of that data becomes available as a community, let's build on it, let's work with it, let's create tools with it, but also as data scientists, I think it's beholden on all of us to help companies who don't know how to handle that take advantage of the many machine learning tools and AI tools that are becoming available. When they first launched Earth on AWS, specifically with Landsat on AWS, they had 1 billion requests in the first year. So clearly people want to work with it, and that is a good thing for all of us. In fact, working with the open source community, we made a viewing tool available because it's all well and good it being there, but you've got to find it and access it. So we work with our partner of ours, Element84, and they've built a viewing tool. Please go and find it on Rhoda. If you've not found it before, ask us afterwards about it. Geospatial data lives on AWS. S3, I think that's 3. We have over 270 trillion objects as of 2023 stored on S3 in all its forms. A lot of the work that I do, whilst we have great, wonderful things like DynamoDB for weather data, or Kinesis for real-time data streams, or Redshift with our partners for petabytes of data sets, is actually data strategy. And working with customers to help optimize data storage, data movement. I think there's about 10 different versions of S3 now, which is IA, Glacier, archiving. We're all facing that challenge of data storage and management, and that's something we really want to help you with as customers, and we obsess over our partners to do so. And so the types of data that we're working with all the time allow us to work with partners, and partners are the lifeblood of AWS. Well over half of revenue AWS comes through our partners. So we obsess over our customers, and our partners are our customers, which means that whilst we may have 112 geometric capabilities in Redshift, partners like Carto add another 46. And that's critical to the success of not just our services, but the use of geospatial data in our community. They analyze, visualize, and develop huge amounts of spatial data sets. We've heard trillions mentioned today. I'm sure that number is going to keep rising. But we have to understand the questions we need to ask of that data. 12 months ago, I wouldn't have thought I'd be talking about generative AI, geospatial for AI. Within 12 months, things have changed. And actually, it's, as I say, it's beholden on us to work with customers and your customers to understand what they can ask of those data sets. It is a tipping point. I'm not sure the word inflection is quite right. So if I have any more inflection points, I'm going to get whiplash. But I think it's important to understand is that there's this massive proliferation of data. Building foundational models with our customers, organizations like Satellogic, Satvu, Maxar, Planet, I'm going to run through all the data. They're creating data sets now. What's fascinating about the industry is they're now building foundational models and you have an API to access the foundational model. And so we can ask more questions. Beware of hallucinations. That's what I'd say. We'll get onto hallucinations in a bit. So because of this scale of requirement to process that data, that's where cloud computing is really coming into its own at the moment. And the machine learning and innovation that we're seeing, and we are pioneers at AWS, and our customers are pioneering all the time to change the questions we're asking. One such customer that we're working with is Made with Clay, who announced on Monday the availability of their mission. They are processing Sentinel-2 data for the entire globe. Bruno Sanchez, who very, very kindly came along and did a presentation, has launched this. Go and look up Made for Clay. We actually are supporting them with a significant number of credits, ask me about it afterwards, to allow them to process the global Sentinel-2 data. Why? We can start asking questions. Where are trees? Where are coastlines? How fast can we get those things? We're also working with Degas out of Japan, and they've already built and launched an LLM with our Amazon Bedrock service to allow farmers, 46,000 farmers in Ghana, to start looking at agricultural practices. I've heard that today mentioned quite a few times. It's community-led capabilities that we're really starting to tap into. Look up Degas, look up the thing. It's some amazing work they're already doing. The point is, in 12 months, this stuff is already happening, and it's accelerating fast. When you work with querying, natural language querying, with Element 84 recently, they've launched, and you can look up the blog, is single trees and empty fields. It's the questions, it's these natural learning questions. Now, I haven't got a slide on this, but I'm going to give you one thing I want everybody in this room to do at least once today. We have something called partyrock.aws. Make a note of it. It's running out there. Go and build an app and do it in the next minute and go and see the outcome. Why am I mentioning that? Is because when customers start realizing what you can do, your imagination flies. But at the same time, as an industry, it's going to be important for us to help guide, inform, and enable organizations to maximize the value from these data sets. 30 years ago, gosh, it's going back a little bit, when I was first working with a Landsat image, it would take, I think, about 48 hours to process one image. And maybe some in the room who remember such days where you had to borrow a bit of compute time if you were lucky to process that image. With organizations like Planet, we're imaging the planet every day. Different sets of challenges that face us now. Working with AWS Cloud, store that data, process that data, analyze that data is possible. Let's do it cost effectively. Let's do it efficiently, but actually let's start answering some of the big questions that we've mentioned already today. Javier got me ahead of this, so I'm going to, agents. Yes, this term agents, even I've learned about this very recently, the building blocks of generative AI applications. What agents can do can include instructions, actions, and knowledge bases. So a classic geospatial project assistant might ask, you're a geospatial data expert assisting users in navigating your organization's spatial data. What knowledge base are we working from? What actions do we want to start doing? We are already thinking differently. We are already engaging. But what's brilliant about it is I've seen organizations that I would never have seen before working in the geospatial industry, asking questions of the geospatial industry. And that's an opportunity for all of us. What data can help me with sustainability reporting? We have data sets on energy consumption at sites. We're going to start seeing agents talking to agents. They can build on existing resources. In this particular example, it might be a geospatial project assistant. Search a catalog. Being English, I love to see UE at the end of that catalog. It's just a frustration of mine. Request access, create project, and all the time we're processing is faster and faster and build those geospatial assets. We've got to think about ourselves as data consumers. The other term which I'm going to use is data meshing. Quick show of hands. Who in this room has tried to create a data lake? A few. Okay, interesting. Well, data lakes obviously become important as we create more of them, but sometimes by the very nature of the data, perhaps licensing associated with that data, you can't move it off. So we're seeing this increasing process of data meshing, accessible by agents. Sorry, there's a lot of information up here, so that's where you can take the photographs. But agents talking to agents. But once again, how are we governing that? You know, governance on these agents is equally critically important. There's a huge amount of value that can be gained, that can be assisted, that can be interrogated. whether you're working at data lakes, whether you're working with data warehouse. But so much geospatial data services that run on AWS today are now moving forward with our customers. So the sort of services that we have, things like Amazon Location Services, SageMaker for machine learning, open data, and our customers like Swiss Topo, which are producing maps, millions of maps every single day for their customers. I know I'm over time, so I will try and wrap up as carefully as I can because I'm running through a lot here. But where that data is coming from is also changing. We have to think about that as well. We've all got devices. The average person has 8 IP addresses. Think about that for 1 second. They had to add an extra 3 digits to the IP addresses just to cope with the number of new devices. Whether it's IoT, whether it's web, whether it's sensors, whether it's mobile phone, laptop, which means the source of that data continues to expand. And location in structured and unstructured format is also changing all the time. When you look at a newsfeed, as soon as there's a name, there's a location. When that location comes up, we can start running analysis. And of course, good old cataloging, enriching, ETL, interoperability. Those are challenges that will never go away. Let's try and make them easier to handle. So, my last slide, I know I'm over time, partyrock.aws. This is a coastal, I literally wrote this on the train on the way down, which is how fast it is now possible to do these things. There you can say, we're looking at sensitive imagery, looking for coastal images. It created the output for that, the query, and delivered on it. There is also text SQL. So for those of you like myself who have for a long time not done SQL Server queries, there's an app that converts text to SQL. Go and use it. It's great. Saves loads of time. Right. Finally, hallucinations. Where are hallucinations? I did say hallucinations. Took an image of this particular interesting place in Seattle near our headquarters. Claude told me very quickly the serial image shows Quest Field, known as Lumen Field. Fantastic, got it right. Awesome. AI is brilliant. It's accurate. So I thought I'd push it. I thought I'd push it really hard. Ground close to my heart, Leicester City Football Club. Any supporters in? Yay. Awesome. Thank you very much. You can get a sticker afterwards. So I said, great, tell me what Leicester City Football Club was. Not there yet, is it? So let's keep working. Right, beware hallucinations, use party rocks, open source rocks as well. You could also train executives if they don't know how to do it. Thank you for your time.